Hey guys, what I got here today is a setup for a non-solar charger of my power system. And if you know my build, you know I do have a solar charging system, but not everybody has the luxury of having sunshine all the time. So if you live up north or something like that, or you like to camp when there's not a lot of sunshine, having solar power is not that great a thing. So what might be a better option is charging through your alternator of your car. So whenever you're driving, you're charging, and that actually charges much faster than solar. So let me show you how to set that up today. Okay, so what I have here is a power inverter. I got this Leap Trend power inverter and a Leap Trend battery charger, and these are much more high end than I'm normally used to using. So that's fantastic. I'm always buying the lowest budget ones, but this is a high end one and it's a high quality one. And let me show you guys. Okay, what we got here is a battery DC to DC charger, and this will allow you to safely hook up your alternator to this guy and then to charge your battery. And I'm going to show you how to do it. And you might ask, why do you need this and why not just an isolation switch? Well, if you're like me and you have a lithium iron phosphate battery, that's your car alternator is not made for these batteries, so it's not always the best option. It will work, but it's not really good for your battery because it's not made for that kind of current. Okay, so if you had something very stable like here, like this guy, it'll regulate the current and regulate the voltage. So this is going to be a lot safer for your system, so your batteries will live longer if you use this type of charging. So let's put that there. Over here I got this Leap Trend inverter. It's a very, very high quality inverter, and I'm going to show you. You could see by the size of it. You're not messing around with this thing. So it's 2,000 watts. It is a pure sine wave, which is very important if you want to run a microwave or something like that. But take a look at it. It looks really nice. It's a pretty design. Another nice thing is that it has an on-off control switch. So with my current inverter, I have to walk over to it, flip the switch, and then use it. But this, I could have a remote switch wherever I'm at, and turning it on and off is going to be easy. So I'm going to show you how we're going to hook this up to my current system. I'm going to use my current battery. It's a 100 milliamp battery. But I'm going to first show you guys out here how to actually do it. Okay, so what we're going to do is we're going to pretend this is your car battery, and we're going to pretend this is your internal battery to power all your electronics and your microwave and all that good stuff in your car. So this is your camper battery, and this is your car battery. Your alternator is tied straight to this battery, so whatever you tie to these pins will be tied to your alternator. So what you want to do is have your alternator go to this DC to DC charger, which will go to your battery, which goes to your inverter, of course. But the battery goes to the inverter. You could also tie it straight to that point where it connects to your inverter, as long as your connection is good. You want to make sure your connections are all nice and strong. What this will make sure is that your charger, that your alternator doesn't push too much current into this battery and damage it or anything like that. It'll maintain not just the voltage but also the current. That's why these are important and not going straight. So I know it's tempting to just go straight battery to battery, and when the alternator is running, it'll charge this, but that's not a good, like I said, it's not a good option because your alternator is made for a lead acid battery, and if you're using a lithium iron phosphate, it is not good for that. Down here, there's D plus line. This is where you want to put in your ignition switch. You know how there are lines that are just live when your car is on with the accessories? That's what you want here for this D. You want that signal to go here to control it. So when you turn on your ignition, that's when it activates the charger, so it's not running outside of that point in time. So that's another connection you'll have to make, not just the two power lines, but also the control. So this will tell it when to start charging and when to stop charging. Over here you could see there's settings for standard batteries, gel batteries, AGM batteries, lithium iron phosphates. So I'm running a lithium iron phosphate, so that's what we'll be setting it to. But you could see it's very specific to what type of battery you have. That's why just using a solar charger, a generic solar charger for your alternating charging is not a good idea. That's why letting your alternator just go straight to any generic battery is not a good idea. You want to have something that conditions that charging signal so that it doesn't damage your equipment. Alright, so here's the DC to DC charger, and there's my little solar charger, and you could see this is just by size alone you just know it's a more robust system. But again, like I said, this isn't made for solar panels, but not for high current. It's made for fluctuating voltages, but this can handle the voltage and the current fluctuations. So with a lot of these higher end stuff, you do have to take into account their size because they are not small. Let's measure it. With the pins, it's probably around 9.5 wide. Almost 7 this way, and 3 inches tall. So my eyeball says it's gonna fit underneath there. Of course, I'm gonna have to clean up my wiring before it fits, but it's gonna fit right underneath that gap under my seat. All right, as I expected, it does fit underneath the seat. So these chargers underneath the seats is a good place to put them since they are pretty bulky and it gets out of the way. Okay, I'm not actually going to put this system in my van in my current build because it's just too big. And the current build, I have the biggest thing that I could actually fit underneath my chair. So I would have to make a new build. So this setup will be for my new build. I just want to show you guys how to set it up today. So my old setup, I actually used another solar charger for using the alternator to charge. It does work, but it's not ideal because the solar chargers are made more for fluctuations in voltages and not so much in current. Your alternator fluctuates a lot in current and not as much in voltage as a solar panel will. So it's kind of backwards. It will regulate your charge, so that's a good thing, but it's just not optimal. It's not made for it like these DC to DC chargers. So this is definitely the way to go. Alright, so what we're going to do with this, guys, we're going to hook this up to my current setup. And my current setup, I couldn't run all my electronics at the same time. Well, all that microwave and all my electronics at the same time. So what I had to do is make sure that the refrigerator was not running while I was running the microwave because it was just pushing the limits. But with this guy, I don't think that's going to be a problem. So we're going to run the compressor of the refrigerator and the microwave at the same time, and maybe even run my coffee maker too at the same time. Alright, so let's compare this 2000 watt Leap Trend to my old Alpha 1500, and you could see this is just a monster. And it is like I said, this is a very, very high-end quality product. You know, this is a good inverter, don't get me wrong. It's a good inverter, but this is a very high-end inverter, and that's why it is so robust and big. So let's measure it. It is almost 16 inches. And that guy is almost 12, and you can see it's much bigger by almost 9 inches, maybe 8.5 by 4 inches. This guy is about 4 inches high and about 5.5 wide. So there's no way I am fitting this guy in there. I would love to, but he just won't fit. So this and the charger will go on my new van build, just not retrofitting to this current one right now. So let's power it up, hook it up to my battery, and run as much stuff as I can. Alright, so I hooked up the inverter to my battery. So let's give it a shot. Alright, so I'm going to use the plug-in option for the refrigerator. There's a DC option, of course, but for this test, it makes more sense to use the plug-in option. Power this guy up. Okay, so this plug right here is going to this guy right here, so I'm going to be able to power up my microwave. So let's first start with the refrigerator. Okay, that tells me that the refrigerator is on. Okay, you see here that it's cooling down. You can see it's cooling down. You can hear the fan going, so the compressor is running at this point. And of course it will, because it's hot right now, so it's going to run until it cools down. Let's move over to my microwave. Okay, over here we'll plug in the coffee maker as well as the microwave. You can hear the microwave just went on. So the microwave is on. The coffee maker will turn on once we put in some water and turn it on back there. So let's run the coffee maker. Okay, so the blue light is on, so that is heating up. You'll start to hear it percolating a little bit. I got some water for the microwave, so let's run everything and see how well this inverter does. I know my old inverter wouldn't be able to do it because it's just maxed out. So let's turn this on. So it's all running. Let's take a look. So I got my coffee maker running. That's around 600 watts, and this microwave is about 1,000 watts. And my refrigerator is running, and that's probably another 100 watts or so. Let's see what this is saying. Well, my microwave just finished, so let me start it again. Okay, so watts wise, this is drawing over 2,000 watts right now, and it's pushing it all. Wow, that's pretty unbelievable. It's 2,000 watts continuous, and I think it's 2,500 peak. So right now it's running 2,100. So wow, that's pretty amazing, all the power that this thing's handling at one time. It's a great inverter. It'll be great for my new build. You can see as soon as the microwave is done, it's down to 720. So that my microwave is taking over 1,000 watts.